Okay, fine. So let's start the session. So in the last class, we are discussing about the NumPy, right? We have completed the NumPy. So where NumPy, whatever the NumPy is there, NumPy is a combination of with respect to for loop plus list. It is a combination of for loop plus list. So now in today's class, we are going to discuss the next concept called as Pandas, nest library. It is one of the most important library in entire Python. So this Pandas, whatever the Pandas is there, Pandas library was built over the NumPy plus dictionary by using the NumPy plus dictionary. So what is meant by NumPy plus dictionary? Okay, NumPy means here, NumPy, what we are going to use in the NumPy means for loop. So for each and every element, it is going to do. For example, if you take a values like 1, 2, 3, 4. So if we want to add 10, okay, if you want to add 10 for each and every value, so that will be very easy in the NumPy or in the Pandas. So wherever the NumPy is there, NumPy means, what is the meaning of NumPy means numerical Python, where it is able to do the for loop. By applying the for loop means for each and every element, the operation will be carried out automatically. So without writing the for loop word, automatically it will do for each one after one. For each of them, it is going to apply by default. Now dictionary. Now what is meant by dictionary? Dictionary means where it is having a key value pair, right? It is going to create the object inside which it is going to create the value by using the key, by writing the key, by considering the key, right? So here, this Pandas was created based on the NumPy plus with respect to dictionary, right? Now let us start the first one. So import NumPy. First, I'm going to import the NumPy as NP, as everyone knows, first step. Second one is, in today's class, we are going to start the next one is called as Pandas. I'm going to import Pandas as PD. Okay, where PD is the standard notation. Wherever the PD is there, PD is the standard notation for Pandas. Generally, we'll import that as PD. And if any library, if you want to see the version, what is the version you are working, and in the future, if you want to check, means for example, some of the functions are not working, whereas in other systems it is working, in your system it is not working, and what is the difference you want to identify? You have written the same statement, but sometimes it will not work because the reason is some versions will be different. Okay, in the previous version, the function will be different and the syntax will be different, or something modifications, small modifications will be there. So that whatever the version you are working, you can check by using the library. You can write the library name dot underscore underscore version underscore underscore. Okay, by writing like this. Okay, library name dot version. So you can check the version, whatever the version you are working on. So here the version I'm working is 1.4.4, which is the latest version, right? Now, in the Pandas, first we are having the foremost one is called as series. The first one we are having the series, right? So in the Pandas, we are having two. One is called as series. The first one is called as series, and the second one is called as DataFrame. Guys, just give me a minute. So in the Pandas, we are having first one is called as series, and the second one is called as DataFrame. These are the two things we main in the within the Pandas. How we are having an array, the concept of array in NumPy, the similar concept we are having in the series and DataFrame. So what is the difference between an array, series, and DataFrame? These three things which we are going to see, out of which already the array part we have completed in the NumPy. Now in today's class, we have to see the what is the series and what is the difference between the DataFrame. Now here the series, I'm going to create a Pandas series by using a table. So here by using a list, here if you observe a list, here the list is consisting of one is apple and the second one is numerical number 42. Two words I have taken, I mean two data I have taken. So here I'm going to convert this list as a pd.series, similar kind of how we have done in the numpy.array of L. Similarly, I'm going to take pd.series. Within the PD, I mean within the Pandas, I'm going to consider the series. Okay, so pd.series. Now by writing this pd.series, now if you observe in the NumPy, if I take the same thing, list is same. Whatever the list I'm considering, the same list. If I'm considering in the numpy.array or pd.series, list is same, L is same. Now in the NumPy, what happens? It is going to create with the np.array. The array it is going to create like this. It is going to create an array in this way. Whereas in the series, if you consider in the series, it is going to take each of them in the column wise. The values will be stored not in the row wise. The values will be stored in the column wise. That is the difference between array versus a series. The values, whatever the values are there, the values are stored in a column wise. So the Pandas series is like a column in a table. So the values will be stored Okay, whatever the values are there, values will be stored in a column wise. And automatically the index numbers also will be given according to that. So whereas in the series, we are having with respect to the values will be stored in the column wise. Whereas in the array, the same thing will be stored in this way. And we are having the index numbers in this way, right? Whatever the index numbers are there. But here, the values will be stored in the column wise. Now, if you ask here, what is the type of estimates? It is going to say that Pandas series. It is a Pandas series. And here the shape, whatever the shape you are having, the shape is also same as one-dimensional array, which is nothing but 2 values are there, which is a one-dimensional array. But array stores the values in a row, whereas series will store the values in a column, right? Next, here the index, whatever the index numbers are there, the index numbers, these here, we are having two things. You have to write in the notes compulsory this one. Index is of two types. Here we are having index name and index number. Two things are there. Two different things are there. Index can be written in the name. Index can be taken in terms of number. Okay. Now here, whatever you are seeing this one, 0 and 1, these both of them, 0 is called as index name. 0 and here the 0 and 1, whatever you are seeing, whatever it is printing, it prints the name only. It will print by default name. So then what is the number, sir? Numbers automatically. It is not going to print, but default the numbers are 0 and 1 only, as everyone knows. In this situation, the name and number are same. In this particular situation, the numbers and names are same. For example, let us take one more different example where list is equal to apple and comma 42. PD.series, the same example as it is, whatever I have done above. L is equal to apple comma 42. Here also apple comma 42. S is equal to PD.series of L. PD.series of L, where index is equal to A comma B. Index is equal to A comma B means here the name should be considered as A comma B. Now tell me what are the here, whatever it is printing, A and B, is there, right? These A and B are called as index names. They are called as index names. Now, what is the index numbers? By default, 0 and 1. Index numbers are not going to change. Index numbers always start from 0, ends with n-1. Similarly, negative indexing starts from -1 to maximum of minus length function till that. Okay, index numbers are not going to change. Whatever it is printing here, it is with respect to the names. Now, so here we have seen how to create a series using a list. Similarly, how to create using an array. Similar. A is equal to np.array, where one dimensional array I'm going to consider apple comma 42. PD.series of A and index of A comma B. Now, what is the difference between above and below? In the output, you can see the output in the above and below. What is the difference between above and below? Means as it is, both are same. There is no difference. So if you are considering true list or true array, there will be no difference because both are same. Array and list are both are same, right? Now, third one is by using the dictionary. I told you Pandas has created using a list, array, and a dictionary. Now in a dictionary, whatever the keys are there, the keys will be considered as the index names. The keys automatically will be considered as the index names and the values it is going to create. Is that clear? Next, in the dictionary, for example, this is the key. We are having the key and we are having with respect to values. Sir, values can be anything, right? Values can be with respect to integer, float, or anything, and values can be even a list also. Now, if I am considering the values as a list, now what happens? So this key is considered as a row name, and whatever the value is there, that value is stored in that particular row, right? Each key is stored in the whatever the key name is there, the key names are converted as the index names in Pandas series, not in the data frame. Series is different, data frame is different. Okay, whenever you are having one-dimensional arrays or with respect to a list, these values can be converted as a series. For example, if you are having a two-dimensional array or nested list or with respect to like that, the values are there, then we have to go with the data frame. In that case, data frame. For one-dimensional, we are having the series. For two-dimensional, we are having the data frames, right? Now, if you ask here the type, whatever the type of S, instead of S is equal to PD.series of D. And if you ask here, it is a series. Now, sir, here we are having index name column 1, index name column 2. Inside that values are 1, 2, 3, 4. Now what is the shape? Still it is a 2 rows. We are having with respect to 2 rows. Okay. So here, whatever the rows we are having, each value, this is the first value. That is list of 1, 2 is the first value. List of 3, 4 is the second value. 2 list we are having. So it is 2, just it is again 2, only. Is that clear? Now, next one is data frame. Now just observe the same example, whatever I have written here, just D is equal to, just observe this example. D is equal to column 1, a list of 1, 2 value, column 2, list of 3, 4. And I have converted below PD.series of D. This one I have converted to series and I have got the output like this. Now the same example, same example, D is equal to call 1 of list of 1, 2, call 2 list of 3, 4. Instead of PD.series, I'm writing PD.DataFrame. And I'm printing this one. Whatever the variable is there, that variable I'm printing. Now, what is the difference? Can you see the difference? If you want, I can bring this one to down. Can you see the difference between both of them? As it is, I have taken. Example, I'm not going to change. As input, I'm going to consider here PD.series of D. D means this one. PD.DataFrame of D, where D is again the same thing. The same example I'm considering. Now, what happened? Here, the index name, whatever the key name is there, the key name is equal to the index name in the series. Now, whereas in the data frame, the key, whatever the key name is there, that is considered as the column name. That is the difference between these two. Okay. And the values, whatever the values are there, these values are not stored in the row wise. These values are stored in the column wise. Here, the values are stored in the row wise. Whatever the value is there, the values are stored in the row wise. Here, the same values are stored in the column wise. Is that clear? That is the difference between the series versus data frame. Whenever we are working on a 2-dimensional, directly we can work on the data frames, right? Next, if you ask what is the type of DF, it is going to show the data frame. It is not the series. It is a data frame. And the shape, if you see the shape, the number of rows into number of columns. Here, how many number of rows are there? 2 rows and 2 columns. 2 rows and 2 columns. 2, 2, right? Now here, whatever the 0 and whatever the 1 indicates with respect to what? Index name. Once again, it indicates the index name only. This is, what is this one? This is column name. So for this example, 0, 1 are considered as, this 0 and 1 are considered as index name. These considered as index names. And whatever these two are there, that is column 1 and column 2. Column 1 and column 2 are considered as column names. Now, index numbers, okay, name wise, okay, sir. Index number wise, this is also 0, 1, row index 0, row index 1, column index 0, column index 1. Okay, both of them are having with respect to. Sir, why you are saying both of them, sir? Why we are confusing? Why name and why this one? Because we can access the elements by using the name wise or by using the index number wise. There is a concept called as lock and there is a concept called as iLock. Lock means location. We can access the elements, whatever the values are there, that values we can extract by using lock or by using the iLock. Sir, why to create, why to extract? Why you are writing, you are only creating the data frame, you are only extracting. Why to write, why to extract? Again, the question. Here, if you are writing a simple example, whatever the simple example we are having, so whatever the example we are having here, in this example, we have created the data frame. We created the data frame. We created a data frame of the two rows and 2 columns only. A simple data frame we have created. But in real life, we are going to extract, we are going to save the Excel sheet. Where in the Excel sheet, we are going to have 1 lakh rows will be there. 1 lakh rows will be there and maybe 100 columns will be there. Anything. A data set may consist of anything. So in the future, we are going to read the Excel files. So in the Excel files, most of the structured data will be stored in the Excel sheet. Whatever the structured data, that is tabular data. Okay, wherever the tabular data we are having, this tabular data we are going to store within the Excel. And once we store this one in the Excel, this data we are going to do the manipulations or the cleaning or the modifications, everything by using the Pandas. For example, there is an Excel sheet. In the Excel sheet, we are having first row, first column, second column, third column, like this. Multiple columns are there, multiple rows are there. This entire columns and rows, everything we are going to read as a one data frame, single data frame. In that data frame, we can extract whatever the row we want, whatever the column we want, or whatever the value we want, or list of values we want, anything we can do. Multiple manipulations we are going to do, right? So much of things we are going to do in the data frame. Of course, from now we are going to do everything on the using the data frames only, right? Now, next we can create the data frame by using the, I have shown you the series. How to create the series means 1 by using the list, 2 by using an array, 3 by using a dictionary. Create a series. How to create a series or how to work on the series. Similarly, how to create a data frame means 1 we have seen with respect to dictionary. I have shown you the dictionary so that the difference you can observe very easily. The difference between the series versus whatever the data frame versus series, you can see that difference. So I have taken the first example with dictionary. Similarly, we can create by using the list also. Data frame can be created by using the list also, and data frame can be created by using array also, and data frame can be created by using the dictionary also. So we have seen how to create using a dictionary, right? Now how to create using a list. So here the list 1, 2, 3, nested list of 1, 2, 3, and a list of 4, 5, 6. Now what I'm going to do, this I'm going to create these values, whatever the values are there, these values I'm going to create as a data frame where 1, 2, 3 and 4, 5, 6, and I'm writing the column numbers, column names as column 1, column 2, and column 3. If you don't write the column names, for example, you have not written the column names, just you have created pd.dataframe of data, just like this you have written. Now what happens, by default the column names will be taken as 0, 1, 2. By default they are the names. Unless you write specially the names, it is not, by default it is going to take the index numbers only as the names. So here I'm going to write the column names. Columns is equal to col 1, col 2, and col 3. Like this I'm going to write. Now similarly, if you want to write the index names also, you can write the index names also. Index, write the word of index, and index names of first one is A, and the second index name I want to keep as B. Okay, if you want to write the row name, if you want to keep for a row some name, then you have to use the word called as index. For column, if you want to keep any name, means you have to use the name called as columns. Okay, is that clear? Is that clear, guys? By default, if you see by default, if you are considering a dictionary, for dictionary only it is going to take by default the keys. Whatever the keys are there, the keys will be considered as the names by default. Only for dictionaries this is possible. For array and for with respect to list, you have to write the names clearly. For dictionary, automatically key name is already available, right? The name, whatever the key name is there, the key name will be considered according to that. The key name will be considered as the row name if you are considering as series. It will be considered as the column name if you are considering as the data frame. If you are moving towards the data frame, right? Next, by using a two-dimensional array. Sir, can I create a data frame by using a one-dimensional array? No. Whenever you want to move on to the data frame, it should be as a two-dimensional. Data frame is a two-dimensional, whereas series is a one-dimensional. Series is one-dimensional. Okay, series entire concept is one-dimensional concept. Data frame concept is a two-dimensional concept, right? Now, here array of 1, 2, 3 and 4, 5, 6, same to same, once again, above and below, right? So here also I'm going to do the same, whereas nested list and array, both are same. Just I'm writing the column names is equal to col 1, col 2, col 3. Index, if you want to add the index means add the index. If you're not interested to add the index means. Now what is the difference between these two? In the first case, you have taken the nested list. In the second case, you have taken the array, two-dimensional array. Both are same. Nested list or two-dimensional array, right? Now in this way, we can create the series and we can create the data frames. Now here, let us start with the first examples. Here we are having a data frame called as pd.dataframe. Don't, here the syntax is most important. pd.dataframe, where D should be caps lock and F should be caps lock. This function was created in such a way. Now in this function, I'm going to take a dictionary where the dictionary is equal to city, Mumbai, Delhi, Bangalore, and Hyderabad. Temperatures are 32, 45, 40, and 36. These are the two columns. So now when I'm creating the data frame, automatically the key names, whatever the keys are there, these keys will be considered as column names. So here you are going to get as a city, and the second one is temperature. Whatever the values are there, these values also will be stored as a column wise. That is Mumbai, Delhi, Bangalore, and Hyderabad. And temperatures are 32, 45, 40, and 36. right? So Mumbai 32, Delhi 45, Bangalore 40, Hyderabad 36. So it is going to create a data frame in this way. If I execute this one, you can see here, Mumbai 32, Delhi 45, Bangalore 40, Hyderabad 36. Is that clear? It is creating a data frame where the values, these key names are considered as the column names, values are stored in the column wise. So just the same example, whatever I have explained earlier here, the same example. Here I'm going to consider this column name and the values. Whatever the list of values are there, list of values will be considered in the column wise. Column name is considered as key name and list of values will be taken in the column wise. Okay. In a data frame, the dictionaries, whatever the dictionaries you are considering, key names will be considered as the column names and the values will be stored in the column wise. Similarly, I'm going to create one more data frame called as humidity DF. This data frame name is humidity DF. This data frame name is temperature DF. Okay. And this data frame name is humidity DF, where I'm having the city is equal to Delhi, Mumbai, Bangalore, and Chennai, where these are the humidities. So I have got one more data frame. This is data frame number 1. This is data frame number 2. You have to write in the notes, both of them. Clearly write in the notes. This example you have to write in the notes. First one is temperature DF. First example is temperature DF. Temperature data frame, where we are having the city and temperatures. City is Mumbai. First one is Mumbai with 32. Delhi with 45. Bangalore with 40. Hyderabad 36. Second data frame we are having is humidity DF, where we are having city and humidity. City is Delhi with 68, Mumbai 65, Bangalore 75, Chennai 70. One is temperature data frame, one is humidity data frame. Two data frames we are having. Now, out of these two data frames, now I want to merge or I want to add these two data frames into one. Okay. Now, first one, combining the data frames. How we can combine the data frames? Option number 1 is called as append. Okay. Append function, because Pandas was created using a NumPy plus dictionary. NumPy means list again. List plus dictionary. By using the list plus dictionary plus for loop is nothing but Pandas. So in the list, we are having the append function. So the same append function is applicable here also. Now here, the temperature DF dot append humidity DF means first temperature DF you have considered. Temperature DF means this is the temperature DF. For this, you have to append the humidity DF. Humidity DF means this one. This you have to append. So this is going to be appended here below to this. It is going to add below to this. So here, if you observe, city, whatever the Mumbai, Delhi, Bangalore, Hyderabad, as it is, the first one is as it is has created. This part is created as it is. And for below, it has created this one. The below to this one was created. Since here the temperature column is there and here the humidity column is there. Humidity column is not available in the data frame 1. The first data frame is not having the temperature and humidity. So here, whatever the humidity, it is not available. So since it is not available, it is showing as none. By default, it is going to take null. The values will be considered as null. NaN means null. The value is not available. Okay, null value. NaN stands for null value, right? So here in the second data frame, temperature is not available. In the first data frame, city is there. In the second data frame also city is there. So these both are combining like this. Sir, assume that here, whatever the second data frame is there, let us create the second data frame with caps lock city. This is a different column. This is a different column. Now you append. Now in this case, you append. What happens? See, a separate one was created. If both of them are same only, the below it is going to consider. Otherwise, a separate column will be created, but below only. This is the first one. Whatever the data frame number 1, below data frame number 2. What you have taken in the data frame 1, first one, temperature DF. So temperature is considered on the top. Below is this one. These are clear? Both are appended to each other. Just both are attached to each other. Right? Now here, there is a drawback with the append function. There is one drawback with the append function. What is the drawback means? It can add only one data frame at a time. For this temperature DF, for example, I'm having DF1, DF2, DF3, DF4, like this, I'm having multiple data frames are there. Now these two I want to add means for DF1 dot append of DF2, I'm going to write. Now I want to append all of them at a time. That is df1, df2, df3, df4. I want to add everything at a single time. Then what I have to do is append function is not applicable at that time. The second option we are having is called as concat. Okay. Of course, anyways, here you can see there is a warning also. In the future, this append function is going to be removed. They are going to remove this append function in the future. As of now, it is available, but in the future, it is going to be removed. In the next coming version, they are going to remove the append function because there is no use of append function. Because whatever the append is going to do, the same thing will be done by the concat also. Okay. So here, okay. Now concat, pd.concat of list of data frames, temperature data frame and humidity data frame. These two you are going to concat. So can you see the difference between these two? What is the difference? Tell me what is the difference you have observed in the output? Both are same, right? So here in the append, whatever we are able to add two things, in the concat also we can add two things. At the same time, we can add multiple things also. For example, we are having 4 data frames or 5 data frames. There we can concat everything into one. Sir, in real life, can you explain with one example with a concat where we are going to use? For example, we are having the January sales, a separate data frame, where in the January, I am having the date versus total sales, means turnover on that particular day. On January 1st, what is the turnover? On January 2nd, what is the turnover? On January 3rd, what is the turnover? Total sales. Okay, total sales, whatever the sales I'm having. This is only January. Similarly, February. Similarly, March. Similarly, April. Similarly, May. Like this, I'm having till December. From January to December, I'm having like that. Now, I want to concat everything into single one. I want to concat everything into single one. Sir, why you have to concat, sir? I want to check myself in a year which is having the highest sales, which date is having the highest sales, or which month is having the highest sales. This type of analysis I want to do means first I want to concat everything. So in that case, we are going to concat all of them. That is pd.concat. You are going to use pd.concat is the function. And inside that function, you have to give us the list of data frame values. That is df1, df2, df3, like this on up to dfn. List of data frames you have to provide as the input. Just to pd.concat. What is meant by pd.concat means it is going to open the pandas.py file. There is an inbuilt module pandas.py file is available. Just it is going to open that particular module. In that module, there is a function called as concat, where the concat is going to take as a list as the input. This function was created by considering list as the input, where you have to give as the list as the input. Every function was created based upon, for example, def add a comma b. Here a can be taken as list. No, right? A can be taken as with respect to int or float values. If you want with respect to a plus b. Similarly, concatenation, string concatenation you want to do. A can be considered as the string. If you want, you have created a function where it will add the sum of the elements in a list. Then input should be listed. So based upon the requirement, how the function was created, based upon the function, we have to give as the input. Now here, whatever the input I'm going to provide is list of data frames. So the list of data frames it is going to add. Okay. Next, if you observe here, in this concat function, this is the first temperature df followed by humidity df. It has added the humidity df, right? Now, if you observe here, this is the index names. What are the, for example, if I'm calling the name with 0, if I call with the name 0, which record will have? 2 records are there. This is the first record and this is the second record. 2 records are having the name as 0 because this 0 belongs to df1. This name belongs to df2. I want to add both of them without considering the index, After concating, then I want to reassign the index numbers. That is 0, 1, 2, 3, 4, 5, 6. I want the new index numbers. Once after concating, I want the new index names. What are the names are there that I want to have the new. Then what you have to do means pd.concat of temperature and humidity df and ignore index is equal to true. In this case, just it is going to do this one. So here, what is the difference means 0, 1, 2, 3, 0, 1, 2, 3. Instead of that, 0, 1, 2, 3, 4, 5, 6, 7. This is the only difference between these two. It is going to ignore the index. First, it will add the data frames. After adding the data frames, reassign the index names. After concating, again, it will reassign from the starting. Is that clear? Now, here concatenation was done by default row-wise concatenation. So this data frame 1, data frame 2 you have done by using with respect to in this way, df1, df2 you have added like this. Sir, I want df1 and df2 side by side like this. Then you can write axis is equal to 1. Now you'll get the side by side. Data frame 1 and data frame 2 you can concat like this, or you can concat like this. Side by side. One is H stack, one is V stack. One is H stack and one is V stack. Side by side. One is side by side, one is down by one after one. Is that clear? Now, sir, if you observe here, in this example, whatever you are concating, I want in this way only. Sir, you have concated, that is first data frame, second data frame. Excellent. Super. Out of which you have given the index names also, new index names. That is also fine. But here, if you observe, Mumbai is there. For Mumbai, temperature is 32. Humidity is none. But for the same Mumbai in the second data frame, temperature is none, humidity is 65. Mumbai is same only, right? So why you can't create like this? Mumbai with a temperature of 32 and a humidity of 65. I want in this way. Then that is called as merge. The concept name is called as merge. What is the difference between the concat versus merge is the interview question for the data scientists. And particularly remember guys, if you know the pandas, simple data analyst, you are called as data analyst. For data analyst role, whoever are the data analysts are there, the data analyst, if they are working on the Python means they simply work on the pandas. Okay. Every data analyst, if they are working on Python means, if the data analyst works on Python, means that is only pandas, one and only pandas. Pandas, if you understand pandas means equivalent to data analyst. Okay. For data analyst role, this is the most important library. Now here we are having with respect to this concat, whatever the concat versus merge. What is the difference? So you see this one and you only tell me. So here I'm having this first one. Okay. Concat. I'm concating these two. And now what I'm going to do, this same thing, I'm going to use pd dot, instead of concat, I'm writing merge. If you observe here, I have written the pd dot concat and here I'm writing the pd dot merge. And here I'm giving as a list of data frames, that is temperature df and humidity df. Here I'm going to give the same temperature df, humidity df, and main in the merger, at least one common column name should be there. If it has to merge means on common criteria. What is the common criteria? That common criteria should be there. Then only it is going to merge. If there is no common criteria, then it is not going to merge. For example, see, set 1 is equal to 1, 2, 3, 4. You are having set 1 is equal to 1, 2, 3, 4. Set 2 is equal to 3, 4, 5, 6. Okay. Set 1 is equal to 1, 2, 3, 4. Set 2 is equal to 3, 4, 5, 6. Now, whatever the set 1, 1, 2, 3, 4. And the set 2, 3, 4, 5, 6. Since both of them are having the 3 and 4, we are going to have the Venn diagram like this. Now, the same example I'm writing like this. Set 1 is equal to 1, 2, 3, 4. Set 2 is equal to 5, 6, 7, 8. Assume this is the example. Now, can you draw the Venn diagram? Means how you are going to draw the Venn diagram? 1, 2, 3, 4. 5, 6, 7, 8. Both are mutually exclusive. They're not having any connection between them. This is if you keep the circles side by side like this, if you attach their circles, whatever the circles we are having, if you attach the circles, still more, if you attach the circles side by side like this, then it is called as concat. If you insert this circle inside that one more circle, if you go penetrate into one more circle, this circle is called as merge. This is concat, this is the merge. If you want to merge and if you want to do something means there should be some common thing should be there. Without common thing, if you are doing means if you merge also side by side only you can keep, then there will be no difference between merge and concat. Okay, if there is both of them are not having any common parameter, then concat versus merge both are same as it is. Now, if you are having with respect to common parameter, what is the common parameter here? City is the common parameter. That common parameter you have to write on. You have to use the word called as on. On means which is the common parameter where you want to merge. Means it is going to take this one as the common parameter, city as the common parameter, and first it will write. So it will write whatever the common column values are there in the 2. First it will take the first data frame. What is the first data frame? This is the first data frame. This is the second data frame. It will take the common city as the common city. First it will write the word as city. It will create like this. After that, First it will fill the Mumbai, Delhi, Bangalore, Hyderabad. First it will fill the temperature DF. Why it will fill the temperature DF? Because in the given code you have written the first one is that one. So first it will fill that. After filling this one, okay, it will write as it is. First one will be written as it is with no doubt. Directly it will write like this, as it is. Now it will observe, since what you have written, merge is the function. So merge function, it will take the common parameter. Is Mumbai is available in the second data frame? It will check whether the Mumbai is available in the second data frame. Yes, it is available. So it is going to create the humidity with 65. Delhi, it is available in the second data frame. Yes, available, 68. Next, Bangalore. Bangalore is available in the second data frame. Yes, available, 75. Okay, next, Hyderabad. Hyderabad is available in the second one. No, not available, NAN. And now, it will come to the second list. In the cities, Delhi, Mumbai, Bangalore, Chennai. So it will check the Chennai also. Chennai. And temperature none. And this is 70. Is that clear? So this is called as merge. Now here, this merge concept is equivalent to in SQL joins concept. The joins concept in SQL is equivalent to merge concept in the Pandas. Both are same. Now in the notes, we have to write clearly in the merge, we are having 4 types of merges are there. Okay. Merge 4 types. We are having 4 types. Okay. Just give me a minute, guys. We are having 4 types, out of which the first type is called as left. The first one is called as left join. Join in terms of in SQL, the same merge function. Whatever the merge in Pandas is equal to joins in SQL. Both are same. As it is, blindly both are same with not even minute difference. Right? So here we are having the merge of 4 different types or joins also. The merge 4 types, we are having 4 types, out of which the first one is called as left merge, right merge, inner merge, outer merge. Total 4, left, right, inner, and outer. Now, what is these 4? Okay. So what are these 4? So don't write simultaneously along with me. Just focus. It is one of the most and 100% guaranteed interview question. Blindly 100% means 100%. Without this, there is no question for data analyst. Okay. So this, whatever we are having, the first one is 2 things. We are having 2 data frames, data frame 1 and data frame 2. Now, what is the thing is with respect to left merge? The first one, I'm going to write the left merge. What is meant by left merge? Don't write simultaneously along with me. Just focus clearly. You can understand easily. The left side part, whatever you are having, the left side part, everything should be included, including the common thing. Left side, whatever is there in the left side, that should be included, everything, including the common. Including the common parameter, it has to consider only on the left side one. This is called as left merge. Second one is called as right merge, where the right side part is everything is included, including the common. It is going to consider right side part. Whereas next we are having called as inner merge. What is meant by inner? Inner means it is going to consider the common parameter. Whatever the common parameter we are having, it is going to take the common parameter only. It is going to consider the common parameter. This is called as inner merge. And the last one which we are having is called as outer. Outer means everything. Everything. Right? So this is called as with respect to right merge. This is inner merge and this is outer merge. Okay. For example, this is considered as data frame 1. You have taken here data frame 1, data frame 2. In the data frame 1, whatever we are having, everything should be there. In whatever the data frame 1 is there, everything should be there. As it is should be there. And common parameters of data frame 2 should be there. Is called as left. Everything, whatever we are having in the left side, everything should be there along with the common parameter. Whatever we are having on the right side, everything should be there along with the common parameter. And inner means common only, outer means full. Okay, now let us understand this one clearly one by one. First, again, I'm saying don't write. Though I have erased also, no problem. Don't write. Just focus, you'll understand. Okay, because this is a 100% guarantee interview question. Okay, not only for interview purpose, in real time, without this, we can't work also. So we can't by heart these things. Whatever we are going to work in the daily cases, we can't by heart. We have to understand, right? So here, the first temperature data frame, pd.merge of temperature data frame and humidity data frame. So in the notes, I'm writing clearly, myself, I'm writing here, first, what is the temperature data frame? I'm writing in the notes, temperature data frame. That is Mumbai with 32, Delhi with 45, Bangalore with 40, Hyderabad with 36. Similarly, humidity data frame, where Delhi with 68, Mumbai with 65, Bangalore with 75, and Chennai with 70. Okay, these are the values which I am having, the humidity data frame and temperature data frame. Now, first, I'm going to start with the first one called as left join. Now, I'm drawing the diagram, left join. Left join means the meaning is left side, whatever we are having, everything should be included along with the common parameter. Right? Now, how it is going to create a data frame? How it is going to create a data frame? First, it will create a data frame. Whatever is in the left means first one. Whatever you have written the first one, that is the left one. That is first temperature DF. Temperature DF, city is the name, Mumbai, Delhi, Bangalore, Hyderabad. Temperatures 32, 45, 40, 36. Complete of the left side, it will take as is. After taking as is, now common parameter means in the second data frame, the same city name is available or not. It will check first. Yes, it is available. For that city of M, what is there in this? 65, humidity of 65. Next, Delhi of 68. Delhi with 68. Next, Bangalore with 75. Now, Hyderabad is available in the second one? No. So, NAN. That's it. Chennai will not be considered because Chennai is basically the right side element. That is the difference. So, left side, whatever is there, for the left side parameters, whatever the common is there, it has to add. If the common is not available, it will not add. That is the meaning of left join. Is the left join is clear? If the left join is clear, now automatically right join. Whatever the right join is there, right side part, everything should be included. So now what it is going to create? A data frame of right side. Whatever is there in the right side, it will create. That is DMB Chennai with humidity of 68, 65, 75, and 70. If common parameter of Delhi is available in the second one, it will add. If not available, not add. Right? Temperature in the second one, Delhi, yes, available, 45. Mumbai, 32. Bangalore, 40. Chennai, not available, none. Is that clear? This is the left join and this is the right join. Is your question is, is the top concept is clear? Out of left join and right join. If it is clear, now you can write in the notes. Draw the diagram, draw the down immediately the data frame also. So now the syntax for the left join. What is the syntax for the left join means? The syntax is just you have to take on. On means which is the common parameter. By using which common parameter you want to check in the both of them. And the second one you have to write how. How means in what type of join? Left joiner, right joiner, inner joiner, outer joiner. Based on that type of join you have to write here. How is type of join? On means which is the common column name. What is the common column name which we want to select and we have to merge. Is that clear? So you are going to get city, temperature, and humidity. Where for Hyderabad, none. And similarly, next right join. If you consider a right join, for right join, you are going to get city, temperature, and humidity with where for Chennai it is temperature is none. We are going to consider the inner join. Inner join means two data frames, whichever is the common parameter is there. In the both of them, commonly it should be available. Okay. So here, first temperature DF. Humidity DF. Two things are there. Don't write simultaneously along with me. Just again focus. This part is very simple when compared to other part. Left and right join when compared to left and right. This is very simple. City, Mumbai, Delhi, Bangalore, Hyderabad, and temperatures 32, 45, 40, 36. And here Delhi is having with respect to 68 humidity, and Mumbai is having with 65, and next Bangalore is having 75, and this is none. Now here this is called as left joint. Whatever we have seen earlier, this is called as left joint. In the left joint or in the right joint, either of anything as per your choice, either of, if the whatever the null values are there, if you drop that particular row, at least one value is null also, you should drop that row, then it is called as inner joint. Inner joint means both of them should be available. If at least one is not available also, that particular thing will not be considered. Inner means intersection. In the both the things, it should be available. Whereas next one is called as outer. The final one is called as outer. Outer means everything. Now here if you consider this one, the temperature, city, temperature and humidity. City is Mumbai, Delhi, Bangalore, Hyderabad, and with Chennai. Temperatures 32, 45, 40, 36. Humidity, whatever the humidity we are having is 65, 68, 75. This is none. And here we are having 70 and this is none. If you include everything, then it is called as outer joint. Left joint and right joint, if you combine, then it is called as outer joint. Both of them. Everything is included is called as outer. Only the common parameters are available is called as inner. Only left side values are considered left. Only right side values are considered is right. That's it. If you consider everything, every null value in that or in this or everything, if you merge everything, then it is called as overall. Everything. Everything means outer. Is that clear? So just here I'm writing with respect to the same by considering the on is equal to city, how is equal to outer. How is equal to outer means everything. That one inside that this left side also missing values, right side also missing values. Everything it is going to consider. Similarly here, inner joint, only the common parameters. In the both of them, it should be available. If at least one of them it is not available, also it will not consider. Is that clear? That's it. Sir, can you explain in a still more simple way to remember? Still more simple way. Very, very simple way. On is equal to city you are considering now. City. How is equal to inner. Assume inner, meaning of inner. Check city in both data frames. In both data frames. And whichever is common city names, select the common city names. Select common city names. In both of them, whatever is there, only select those city names. In commonly, it should be available. In the both of them, commonly it should be available. How is equal to in outer? All the city names. All city names, right? Write the list of all the city names. Every city name, right? How is equal to left? Right only. Select only left side city names. Left side, left DF city names. Don't select the right side DF city names. How is equal to right? Select right DF city names. Whatever the right side city names are there, select all of them. Select all the city names of right side data frame. Select all the city names of right side data frame. Select all the city names of left side data frame in the left. Select common city names in both of them. Whatever the common is there. In the both of them, common city name, whatever the common is there, that one only you select. Is that clear? Just observe here. So here I have written with respect to first left. Left means whatever is there in the left side data frame, all the city names you write. All the city names in the left side. Right side. Right join means whatever is available in the right side data frame, write all the city names. Because you are merging using the city name now. So write the city names. Inner means what are the city names are both of them are having, write only those city names. That is inner. Outer means write all the city names in that in this union. This is A union B, this is A intersection B. Is that clear? In anything, merge means at least one common column name should be there. Then only it will merge. So for example, I'm not having the common column name, sir. For example, df1 has a different column names and df2 is having a common different column names. Then there will be no difference between concat versus this one. In the concat, how it is going to work? In the similar way, merge also will work. Then there will be no difference. What is the why we are doing this one? What is the difference here? Here, what is the difference between this one versus your outer join? The question is, interview question is this one. What is the difference between concat versus merge? Now in here, the concat, whatever we are having, it is going to concat irrespective of combining the common name. Irrespective of common name. For example, here you are having a normal small city name, small city. You are having caps lock city, city temperature, caps lock city temperature. I mean humidity. And here the Mumbai will be considered. Here also Mumbai will be considered. 2 times the Mumbai was repeated. Here the same thing was repeated 2 times. In order to remove that one, we have to do. What is these 2 common? Which one is common? Means city name is the common. So common parameter is there only we can merge. If there is no common parameter, it is called as concat. Is that clear? So in today's class, till now we have discussed series, data frame, and how to combine the multiple data frames. The data frames how to combine, that is by different options. First option we are having is append option. Second is called as concat, and third one is called as merge. So what is the difference between append, concat, and merge versus merge? Where merge, it is going to merge based on the common parameter. It combines the data frame, based on common parameter, that is common column name, on common column name, using common column name. Whereas concat combines the data frame, just it combines the data frame, Append is also combines the data frame. Then what is the difference between these two? Means it can combine only 2 data frames at a time. It can combine 2 data frames only at a time. It combines multiple data frames at a time. Okay, that is the difference between append versus concat and concat versus merge. In the future, we are not going to have the append. Append is not useful. Only majorly we are having only these 2, concat and merge. Is that clear? Sorry, you can write. Just a minute. Right. Sir, if you don't mention the type of merge, it will consider by default. By default, it is going to take outer. Demo na. Variable. Yes. So just you can open with respect to by clicking on the shift tab. Just click on the shift tab and you can see, and you can merge with respect to multiple data frames also. Okay. Next, most important part comes with respect to now how to load the data. There is an Excel file or CSV file. Now from now here, if you observe this one data types here till now, whatever the data types are there, these data types here, if you create the data frame or with respect to this one, it has shown you some kind of int and it has shown an object, all these things. Now I'm going to explain the data types also. These data types now you'll understand. Okay. So here we are going to import the data or we are going to load the data. In our system, we are going to have some kind of Excel files. Okay. As everyone knows, Excel file. So here we are having 2 different types of worksheets. The first one is called as Excel sheet and the second one is called as CSV file. Okay, 2 files we are having. Just if you observe this one, here we are having one is called as Microsoft Excel worksheet and the second one is called as Microsoft comma Excel comma separated values, CSV file. This is called as CSV file. CSV means comma separated value. CSV full form is comma separated value. So if you right click on this for this function, whatever this particular file is there, this file, if you right click and click on the properties, okay, just if you click on the properties, here you can see here there is an extension called as CSV. Okay, .csv. What is meant by .csv means the values, whatever the values are there, they're stored in the comma separated. So what is meant by this comma separated? Let us observe. So here Let us open this file. Inside this file, we are having certain records. Records. Now, from now, we are going to discuss the rows. Whatever the rows are there, the rows are called as records. Each row is called as a record. First record, second record, third record. Like this, total we are having here 10 records. Okay. Each row is called as a record. Each row is called as a record. Each column is called as variable. Each column is called as variable. Each row is called as record. Each column is called as variable. Whatever the column name, each column name is called as variable name. Each one here, age is one of the variable, gender variable, TB variable, DB variable, TP variable. These are the variables, variable names. Okay. Now here, if you observe this one, everyone feel this one as an Excel sheet. Yes, this is also basically an Excel sheet only. The only difference is here I'm going to click on the save as. After clicking the save as, now here we are having with respect to multiple options are there. If you observe here the multiple options, out of these options, one of the option is comma separated value. Now what happens when I'm going to execute this one and I'm going to click on the save, this file will be saved as CSV file. Means what is CSV file means? In the backend, the values are separated like this: gender, TB, DB, TP, liver patient. And second, these row values will be saved in this way: 65, comma, female, comma, 0.7, comma, 0.1, comma, 6.8, comma, yes. Each value will be saved by using a comma as a separator. Comma as a separator, the values will be saved in the backend. Sir, now what is the use of like that? Let us see this one. I'm going to click on the save as, and after clicking on the save as, I'm going to click on the Excel workbook. Now here, instead of this one, I'm going to select as a CSV file. Whatever the comma separated file is there, I'm going to select this one. And this liver, I'm going to name it as some name. Whatever the name you are interested, you can write the name. I'm going to write the name called as CS. And where I'm going to save this file? On the desktop. I'm going to select the desktop and I'm going to click on the save. Now, if I open my desktop, so here the desktop, it has created a file, CS file was created. Now, if you click on this CS file and if you click on the properties, and here the properties, you can see here, this CS file consists of as a CSV file. It has been stored as a CSV file. And here the space it has taken is 274 bytes or space in my hard disk. It has utilized 274 bytes. This worksheet, whatever I have saved, it has utilized 274 bytes. Now let us open the same file. Again, I'm going to click on the save as. Again, I'm going to click on the workbook. Now, instead of using the CSV, I'm going to use as a Excel file only. And let us write it, the name. I'm going to keep the name of this one as EX. And I'm going to save as Excel workbook. And I'm going to click on the save, where I'm going to save again on the desktop only. I'm going to select the desktop and I'm going to click on the save. And after saving, now, can you see here one EX file was created? Now this EX file, I'm going to right click and I'm going to show you the properties. Now here, whatever the file is there, this file was created, this Excel EX file was created by using XLXX, which is an Excel sheet. And can you see the space? Whatever the space which was utilized? 9,248 bytes. When compared to this one, the space is very less in the CSV. So everyone will save the Excel files in the CSV format. They will not store that one, though it will look as an Excel file only. If you open this one, sir, if I open this one, just open. I have opened. What is the name of this file? EX file. Can you see in the top EX name here? Okay. And I'm going to keep this one side and I'm going to open this one also. So this file, and I'm having one more file, this one, EX file. So I'm going to, one is EX file and one is CS file. One is EX and one is CS. EX file was saved in the Excel sheet. CS file was saved in the CSV format. But both of them are containing the same data. Both of them are having the same number of records, same amount of values, same amount of columns, everything same. But whatever the space was let utilized in the CSV. So why it is taking less space in the CSV? The reason behind that is 65 comma female. Immediately it is going to create the comma. Means after the 65, whatever the space is there, it is utilizing that space. In the Excel file, what happens means in the Excel file, the values are separated based on the tab separated values. Means instead of one space, 8 spaces are taken. gap between the two values, 65 and female, whatever the 65 and female, in between this space is there, right? This space is unnecessarily wasting. 8 spaces are getting wasted. That was the space was converted to a single comma. Now what happened? The space was saved. Here the only difference between both of them is size. Nothing else difference. There is no difference in between both of them, just the size. Now recently all the files, whatever the Excel files are there, every Excel file is getting saved in the CSV format only. All the files, everything they are going to store in the CSV format in the real life, in the companies, because in order to save the space. Sir, why to save the space, sir? This is only 1 KB. This is also less than 1 KB only. For 1 KB also you are finding that much of. Here it is a small data, so we are not able to find the difference. But if you are going with a large amount of data, then you can find the difference. And that too, in the database, we are having a limited space only. The space is more important. In order to store the new data, the database, if it is getting filled, then what happens? Okay, the space is important, right? For example, if you see in my system, in my hard disk, whatever the hard disk I am having, here in this hard disk, I am having this one, 154 GB is free as of now. If this 154 also I have filled off, if I want to add a new data, some other new data, then what I have to do? I have to remove some of them, right? Otherwise I can't do. Or I have to purchase a new pen drive or with respect to external hard disk or something like this, right? If this, sir, now if you feel that, sir, my system 200 GB is free, you are not utilizing. You are not utilizing means in the real life, everyone not utilize, right? Others will utilize, right? Others will have with respect to complete hard disk will be filled, right? So the same. Now, whatever the CSV files or Excel files are there, that CSV files or Excel files, we are going to load into this one. And here, whatever you are having this one, see this lever, whatever we are having here, age column. Okay, these are the columns, whatever the age, gender, TB, DB, TP, and liver patient. Total how many columns? 1, 2, 3, 4, 5, 6. 6 columns and 10 records. 6 columns with 10 records. Whatever we are having the entire data, this entire data I'm going to load here by using this. The Excel sheet, whatever the entire Excel is there, the entire data in the Excel sheet, I'm going to transform into the Python. Just by writing one line of code, read_cs Excel. The same thing if you want to write in the Java means you have to write 6 lines of code. But here, just by writing just one line of code called as read Excel is the function. By using the read Excel, we can read the Excel files. By having the function name called as read_CSV, we can read the CSV files. Once we load the data, now we can start the analysis. The first step is load the data. After loading the data, we'll play that with the data, right? So this data, whatever the data we have got, we are going to work on this data. How to load this data? That things we are going to discuss in the tomorrow's class. Okay, please prepare. And in tomorrow's class, we are going to load the data. And from now, we are going to have this type of data and we are going to analyze. Okay, now actual data science course starts. From now, actual data science course starts. Now, till now, we have discussed only programming. Now, analysis part, whatever we require in this, I want only this particular row. Whichever the row I'm having, this row I want. In this, how many males are there? How many females are there? With the females, what is the average age? With the males, what is the average age? Like this. Everything we are going to start working. That we are going to see in the further class. Is that clear, guys?